Hi, and welcome to our fifth virtual series for the GDG Surrey Dev Fest. As part of Dev Fest, we are conducting several virtual series where we connect speakers from all over the world to speak about their favorite topics. A little about GDG Surrey. We are a not for profit organization focused on education, technical awareness, and community. Today we have Ananda speaking about leveraging AlloyDB and Vertex AI for LLMs and RAG-based chat application. Welcome, Ananda.
Hi, Ria and everyone. Thanks for having me today.
All right, I will stop sharing now and over to you.
Yeah, thank you, Ria and team. Let me share my screen first. Okay, I hope you all can see my screen. Oh, sorry.
Yeah,
Yeah,
yeah, okay.
thank you. Yeah, thanks everyone. Thanks for having me today. Today, I would like to discuss about AlloyDB and Vertex AI for LLM and RAG based chat application. My name is Ananda. I'm a Google developer expert for modern architecture, and I'm a cloud and DevOps engineer in Singapore. So actually, I'm in Singapore. Here in morning, I like 8 a.m. now. So like I would say that good afternoon, but then now here's a good morning. But nevertheless, I'm happy to like share something outside of Asian, meaning that this I hope that this will be useful for all of you. Then yeah, please keep in touch with me if you have any questions. Please do let me know from by LinkedIn or any social media. Feel free. And yeah, we'll discuss about LM and RAG based chat application. Okay, I have a quote here. The future AI isn't just in generating human-like response. It is in augmenting those response with knowledge from the real world. Meaning that, for example, uh, somehow when you like prompting in, for example, Gemini, probably you'll get like a different response that you want. Then because actually the Gemini doesn't know the context, so like by leveraging the LODB, by I mean, actually, it's not only AlloyDB. You mean you can use any other database, your own data, so that the prompt knows the context, so that the response will be better. Hopefully, yeah. Here it says those response with knowledge from the real world, because the prompt, the model knows the context itself. So, get first from the basic. What is an LLM? Stands for a large language model trained on a fast text to understand and generate human language. For example, like Gemini, ChatGPT, Llama, then so on. So then the purpose is first answer questions, summarize and translate text, write code, and assess content creation, for example, generating image, video, and so on. And what is RAG is a retrieval augmented generation. So like combine external knowledge retrieval with LLM based text, then improve accuracy by pulling in relevant. So like yeah, as I mentioned before, probably like to make the response better, uh we can like enhance with the external data, for example by using a AlloyDB as a database to improve accuracy by pulling in relevant and up to date. Because like yeah, probably in different model they are using a different uh, data, and to make it up to date and relevant with our, for example, we have travel agent applications in for specific country, so make that the response more relevant only for the specific country. So like we can use RAG. Then to make it like yeah, for example, because somehow the LLM is maybe outdated or incomplete, then also like avoid costly model retraining by using live, trusted, and authoritative data source. So like yeah, because by streaming, for example, so like rather than using live streaming model, so we can leverage AlloyDB as our database to combine with RAG and LLM, so like to avoid costly as well. So why is RAG important? So like there are some challenges that we may encounter. Then by using RAG, we can solve those challenges. For example, presenting false information when it does not have the answer, because like the model doesn't have context, right? So to make the answer like correct, so then also presenting out of date of generic information. Yeah, when the user expect a specific current response, and also creating a response from a non-authoritative source, so to make the sources more credible. For example, like from the university, like rather than using a random source, they can use RAG, their own database, then like the journals more credible that the the students can use. And then creating inaccurate response due to terminology confusion, wherein different training sources use the same terminology to talk about different things. Yeah, probably like we want, as I mentioned before, for example, the travel agents for a specific country, to make it like more relevant and accurate. So yeah, RAG is one of the great uh, options that we can use. Yeah. So the benefits of using RAG first, cost efficient implementation strategy, because we skip expensive training. Yeah. So rather than to retrain from the live model, so like we will directly get the data from the database itself. And also real-time access to information, always current and relevant, because we provide the data itself, and also source-aware outputs include reference or citations for trust, greater developer control like manage data, behavior, and access secure. Then Yeah, how LLM works. First, receive user query from chatbot or application. I show you here. So first, if we receive user query from chatbot or application, so here. So the first one is prompt and query. Whenever user prompting or like query something here from the front end, then like retrieve highly relevant document via vector-based search here query, then it will search relevant informations from knowledge source. And here today in the specifically we will use AlloyDB itself, because actually like GCP not only provide AlloyDB for the vector basis for the database itself, we can use others. I show you in details later. Then also augment the LLM from with contextual retrieve information. Yeah, so once the knowledge shows found the data, they'll send back the relevant informations for enhanced context. Okay, so I found the answer here, then it'll get back the response. Then generate accurate response using both training and new data. So like based on the data, then uh, by leverage the training itself to make it more accurate. Then here prompt and query. Here then generate text response. So like yeah, update the external source regularly for freshness. So after get the data from the knowledge source, then by leverage the training data, then it will generate the response, then prompt query, then will send back the correct answer here. Okay, so these are example only. Uh, for example, in a specific regions, we have a database for data ingestion for subsystem. Data ingestion subsystem for RAG. Then this evaluation trigger. This the workflow within the GCP itself. RAG for data evaluation from and so on. Okay, this is another example. I mean, in terms of like what the example use case that probably everyone or someone use when they want to like leverage the RAG here. For example, like there is a pops up for event driven applications. So these the event driven applications like for example data upload here in a cloud storage bucket and trigger the event to run some function in the cloud run, then we'll get the like generate embedding like for example the text with Vertex AI. So here what's the purpose of using AlloyDB? For example, like prompt for evaluation, embedding job config and so on. This is just a sample, and then the right side, this for the observability, using cloud monitoring, cloud logging, and then to analyze, to see the logs, for example, for the responsible AI checks, for example, and so on. Okay, what Google Cloud product and service are related to RAG? The first one, Vertex AI RAG engine. Vertex AI search. For RAG engine, like for this data framework to develop contact LLM applications to and facilitate the RAG itself. And then Vertex AI search. The demo that I'll show you will use Vertex AI as well. Then Vertex AI vector search, BigQuery to train machine learning model, include like model for Vertex AI vector search. Then also grounded gen API and AlloyDB AI. Okay, this is the diagram that I'll show you uh, in the demo today. So here I will create a simple LLM based app. Then I will use Vertex AI for the uh, platform, and then I will use LLM model provided by Vertex AI itself. Then I will use Cloud Run to deploy the app. Then AlloyDB for the vector search base for the database itself. So like uh, here the applications will not send the response directly by leverage the LLM, but then it will like ask the database whether they have the data for the to make it the context better than by leverage the uh, LLM model in the Vertex AI. So then, okay, based on both those LLM model and then AlloyDB, I will give you like more accurate response to the users itself. Okay. Okay, so the key components of the system here first, the AlloyDB. Okay, what is the AlloyDB? This is a managed scalable database for storing large data set. So actually, right, if you sorry. So actually, if you are familiar with Cloud SQL in the GCP, and also probably you are familiar with uh, Cloud Spanner. So actually, right, in the Cloud SQL, GCP provide multiple engines, right? For example, MariaDB, MySQL, and then PostgreSQL, right? But then that one like the good things provided by Cloud SQL is the open source itself. So whenever like previously you use open source for database itself, then uh, you migrated to GCP, you can use Cloud SQL itself because they're using the same engine for the backend itself. But then you want to leverage like the native feature by GCP, but I'm using MySQL or MariaDB. So yeah, you can use Cloud Spanner the because it provide like horizontal scaling and so on. But then how if my on-premise database is using PostgreSQL, but then I want to leverage the native feature in GCP. Okay, so the answer is AlloyDB. So the key difference is AlloyDB is using PostgreSQL uh, engine as a PostgreSQL as a backend engine, and then the Cloud Spanner is using MariaDB or MySQL. But those are both native database provided by GCP itself. So actually, if you want to use like other vector database, for example, the cloud spanner, that absolutely possible. Because now, why I'm using AlloyDB, because my data in the AlloyDB, then they provide the vector search databases. Then also the second component is Vertex AI. Provide access to Google powerful language model for natural language. So this one like a platform. Vertex AI provides a lot of feature. One of the feature like I show you before, right? AI, energy engine, AI search, AI vector search, and even like agent builder and so on. Then the third one is retrieval-augmented generation, combine LLM with search-based system to fetch relevant data. So like by combining both the AlloyDB and then the Vertex AI LLM model, we can like get more relevant and to enhance the response itself. And the fourth chat interface, a front end application where users can interact with the system. So just a simple front end application that we will deploy in the cloud run. So yeah, what is AlloyDB? Yeah, fully managed Postgres based database for scalable high performance query. So yeah, as I mentioned before, it's a Postgres based database. Then it optimized for analytical workloads and real-time retrieval. And how AlloyDB fits in? First, it stores a large set of document, user interaction, or knowledge base for easy retrieval. For example, like yeah, the use case of querying a database for customer information, or because, for example, you are working in a company, then your company has developer knowledge, for example, the API knowledge or the documentation itself, but then uh, you want like the user, you want to build a chatbot like for Q&A. So whenever the user like have a questions, then they will ask from the bot itself, and you want the bot is like retrieve the informations from your own database. So that's the and also, for example, the travel agent, for example, like uh whether the user wants to ask like the flight schedule, how to change book the or check in online, for example. So like they will get the relevant or the correct and real-time informations from the bot itself, because we are using the RAG. Okay, so the next, leveraging Vertex AI for language understanding and generation. What is a Vertex AI? Is a platform for building and deploying machine learning model, and then includes pre-trained models for language understanding, generation, and specialized NLP tasks. Then how Vertex AI enhanced chat application first provides access to GPT-like models to handle natural language, then can be fine-tuned for specific tasks. For example, customer service FAQ generation. Mm. Then retrieval part of LG fetch relevant data from AlloyDB, then Vertex AI generate context-aware response. So like the front end, the application will not send a response, like send a raw response, but then by leverage both Vertex AI model and then AlloyDB, it will like generate a context aware response. Yeah. So, okay, integration and workflow of the application. So the workflow for the application: first, user input, user submit query through the chat interface. Then RAG, the system query AlloyDB to find relevant document or data. Then FortiAI process the retrieve data to generate response that is contextually aware, and then the generated response is sent back to the user. Okay, then key benefit, yeah, scalability. LLDB handles large dataset, ensuring fast retrieval, accuracy. RAG improve response quality by supplementing LLM generated uh, content with external knowledge, and then efficiency. Uh, because yeah, Vertex AI provide language model backend, quick deployment and fine tuning. Okay, so okay, sorry, give me a minute. Okay, next. Okay, this demo here. I have yeah. So I provide demo for today, like from this is a very basic lab. Then and from scratch, and then how actually this hopefully that you will get better understanding of how AlloyDB and Vertex AI will works together to create a RAG based chat application. So yeah, and this is a customer sample, so you can try as well in your own lab. Then if you have any questions, please do let me know through the chat or social media also fine. Okay, I will. Okay, this. Okay, I will open the. Okay. Okay, first, before you begin, make sure you have a Google Cloud project and billing enabled. So this is the requirement. Either you have like a trial that should be fine also. Then we also the second one, set your project ID. So now we will leverage. We will do the demo via CLI, and then this just like because we'll use the project ID for like the several steps. So to make it easier to get the project ID, we can store it in the environment variable, and then we set the project for the current CLI, because probably you have multiple projects that currently active. So we set the default project by using set project command. Then enable API. So I assume in the demo, I assume that you just create your own project, meaning that like no resource there, no APIs are enabled. But then actually, this just to make sure that all APIs are enabled, because all the resources that we will use in the demo will use the these APIs as well. For example, the AlloyDB, Compute, Cloud Resource Manager, Service Networking, VPCIs, Access, App Platform. App Platform is the API for Vertex AI. Artifact Registry to store the image, and yeah. Okay, I show you the console. Give me a minute. Mm. Okay, here I have my own project, the project name, the project ID. I just create a new project here, then I open the CLI here. Okay, okay, I export the project ID here. Okay, it takes time. Uh, when you, because it's a really new project, so like it takes sometimes to provision the cloud. Okay. Okay, I set the project ID here. We get the project ID from here, project info section. Just copy and paste. Then I set the Gigla project, but this is the optional actually. Okay. Then yeah, we enable the API here. Just copy and paste. Okay, it may take some time. Okay, I show you. After we enable API, we finish the requirements, the prerequisite steps. So the next one we will create the AlloyDB cluster. Then when I show you the topology, right, the architecture, actually we want to deploy the Cloud Run and AlloyDB. We want the Cloud Run connects to the AlloyDB via VPC, via private connections, right? So how to aside of to reduce the latency, we want to make the uh, because that the probably like there is a security concerns, right? We don't want to use public connections, external connections. Then how to make like the connections in private, and to reduce the latency itself. So yeah, now in the demo we can use like the private service access. So by using the private service access, then the AlloyDB will be able to connect to your own VPC. Okay, so yeah, we'll use the peering connection here. Okay, I export the range name and the descriptions. This is the allocated range default. So the AlloyDB will use this range for the peering connections. Uh, yeah. Mm, okay. Oh, oh, seems freezing. Okay. Sorry, I got an issue with my connection. Then let me share my screen again. Yeah, yeah. Okay. 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 So yeah, we'll create peering connections between the Cloud Run and AlloyDB. Okay. Uh, I copy and paste the environment variable here. Then I create a allocated IP address range. So why we create the allocated range? So like the AlloyDB will use the IP only from this range. Excuse me, sorry. Then create a private connection here. Yeah, we create a pairing connection with that range that we create before. And then the network section here is the VPC name. So for example, I'm using a default VPC, but if you have your own VPC, you can customize here. Okay. Yeah, I copy and paste. Then yeah, after that, we'll create a LLDB cluster here. So create a single cluster, name my LLDB cluster with an in a single cluster I will create only one instance, my LLDB instance in the specific region. Then this is the username and the password. Okay. Next time. Okay. I just export the environment variable, then use a gcloud LLDB cluster create command to create a cluster with those respective parameter. Then I'll create a primary instance with the gcloud LLDB instance create command. Okay. Here export, then I'll create a cluster. Then it's a primary instance. Okay, it takes sometimes, but we can monitor the creation process uh, in the AlloyDB dashboard. So here you can like go to the AlloyDB cluster here. Then yeah, it shows ready. Then we will create the primary instance. Because now when we see the cluster, it shows like empty instance, right? So now okay, when we create the instance, it will show one instance, my LLDB instance. The status is currently creating. Okay, while we're waiting for the uh, class instant creation, the next one will create a VM instance and install Postgres client. Because the AlloyDB now is in a specific, I mean, the goal is actually I create a VM instance, then I want to connect the VM to the Postgres, the AlloyDB cluster via PSQL command line here. Yeah, Postgres client here. So this is something like a jump host. By using this, so I'm able to access the database itself. So here, okay. Oh, sorry. Mm. It's so still creating, but then we can create a new type to create the VM instance here. Then you just select the project here, like click the drop down, and then like I click on the advanced. This is the project name. Okay. Then I create the VM engine itself. Okay, here then I will, once the VM instance has created, then we'll connect using gcloud compute SSH, then the VM name. Okay, we got the IP, and then the status is running. We can monitor again, we can see from the VM instance dashboard also here. Then we will see a new instance name VM here. Okay, then we SSH the VM. We go into the VM. Then we will install Postgres client package. Yeah. Okay. We install, then okay, I check the Postgres, so you're still creating. Okay, I'll go back to the AlloyDB first to check the status. Okay, still okay. So actually, if you see here, right, the instance, you will see the private IP address, because now we are using the default VPC, right? Then we create a range before. Then the instance will use an IP from that range actually. Okay, with the default port 5432. Then how to connect to the AlloyDB instance here? So like we retrieve the IP, we define those parameter. Then yeah, we get the IP first. Then just run with the PSQL command. Okay, but then still creating. Let's try. I don't think it will work. Yeah, we need to wait. Instant IP. Make sure the IP is correct. I get the IP 10.94.0.2. Okay, the IP is correct. Then okay, not yet, right? Okay, okay, I'll show. Sorry, I forgot. Okay, not yet, because now the instance is still creating. So when I try to connect shows that connection refuse. Okay, I'll show you the next step. So the next one is create a vector database. So because now we assume that we're able to access the database within the AlloyDB, then we made enabled embedding vector embedding feature in the database here, and then we install Python. When then we populate the example database. This one I got from the GCP repos. Then yeah, we this like travel agent from. So I'm using the airport data. This dummy data. Okay, let's try again. I think okay. Still valid. Okay. Oh yeah. Then after we populate the example data, then we'll create a service account for retrieval.
Sorry, Ananda, can
Yeah.
you share the link, the GitHub link on the chat too, so that for people to, I think they missed the QR code.
Oh sure, sure. I posted in the chat. Oh sorry, I posted wrongly. Okay, sorry. Here, yeah, can try to access. Thanks. Yeah, if you have any questions, do let me know. The next one is create a service account for retrieval service. So actually within the GCP, how the service connect each other, the answer is using a service account. So by using a service account, the cloud run, for example, will be able to access to retrieve to AlloyDB itself. So now in this repo, I will like create a service account name, create a retrieval identity. Then I'm adding a policy binding to bind the member. The member, this one is the service account for the retrieval identity with the role of AI platform user. So like I'm adding a role AI platform user, so it will be able to access the Vertex AI and then AI things as a user. Yeah. Then yeah. Otherwise, you'll get permission denied issue there. Oh. Okay. Now okay. We go back to the GCP. Now the creating instance is done. Then the status shows ready. Then when I like try to access, now I'm able to go in the database itself. Okay, the next step. Yeah. Okay. Okay, we exit first. We'll create a new database. Uh, but using a specific user. Assistant demo. The database name is assistant demo. Okay, exit first. Okay, create database. Then we enable the vector embedding in. Okay, then we'll install Python. Um, Yeah. Then we'll populate the example. Sorry. Yeah. Here. Create the database and then enable the factor embedding feature. Okay. I clone the repo here. Then I'll verify the data model using cat command. Okay. Retrieval service. Okay. Oh. I. Oh. Okay. Get models.py. So this is the model that the Google define. Then also to see the model and then to see the example data, we can use a head command. Okay. Give me a minute. Okay. Here, this is the data. Name, city, country. This is just a sample, dummy data. To see a sample of the flight data. Okay, this is the flight example. To see a sample of amenity data. Yeah, this is to see how how's data looks like here. Then okay, after that, after we review the data from the repo itself, so I'll create a database configuration file here. Okay, I just copy in. Oh. Oh, I know. Template. Model. Give me a minute. Oh. Okay, wait. I know the issue. No, sorry. Okay. Yeah. Okay. Yeah. Then we'll create the database configuration file here. Just copy and paste. Okay, so we replace the insane IP, Postgres user, password, and then the database itself with our own configuration. For example, the IP and then the database name, password, and user. It's just an sample. Oh, sorry, I forgot to share. This one. We replace the configuration with our own data. Okay, then we populate the database here by using this command. Okay, here it run the install the library. Then we wait. We will run database init command. This to populate the sample data in the repo to our AlloyDB. Then as I mentioned before, though we'll use service account to like make the cloud run able to access the AlloyDB and then Vertex AI itself. Okay, here now finish. Okay, then we copy and paste here. Oh, sorry. Oh, oh, sorry. I know the issue because mm, not the issue. Yeah, because now here it shows right the API, the IAM API is not enabled in the project. So like, okay, actually like in the very beginning of the demo, right? I show you that we enable multiple APIs. But then if we miss to enable one of the API, it will show something like this. Like the API is not enabled, then we need to enable first. Yeah, and then I missed to enable a IAM API. So that's why it will show something like this. Then okay. Wait, let me check. Oh, okay. Already exists. Let's check the IAM. We may need to like remove first the service account. Yeah, this one. I'll try to delete here. Eh? Why? Oh, let's try in here. It seems that the CLA brown case issue. Oh yeah, I'm not sure. This is something like a glitch issue. You see, right? I'm using a different CLI but then it shows different error. So sometimes I try to either refresh the page or like use a different terminal. Yeah, like glitch or keys issue. Okay, like nevertheless, okay, we have updated the service account and binding the AI platform user role to the service account. So now, if we create a Cloud Run, then use that service account, hopefully that Cloud Run will be able to access the AI platform in the Vertex AI. Okay, now the next one will create a retrieval service in the Cloud Run. So yeah, we will deploy the Cloud Run using run deploy command in the US Central. Oh, okay. Yeah. Now, yeah, enabling API. Probably like we missed to enable the API. Then, okay, we create the Cloud Run service. We can go to Cloud Run. Sorry. Okay, wait, let me refresh. Okay. Let's try again. Okay. Okay, now yeah. Now it's still building. Okay, so we go to okay. Here I'm in a Cloud Run, then I refresh the page. Oh, haven't. Okay, we will wait the wait, I think flow. So okay, now I want to show you something, but I forgot where. Just wait a minute. I want to show you like how the cloud run works, but there is a diagram because actually, right, the thing is cloud run, when we creating a cloud run surface, the surface that interact within that process is not only cloud run, but also like the artifact registry, and then the cloud storage, and I forgot where is the diagram. Here or no? Not here. Not this one. Give me a minute. Okay lah, never mind. So actually, right, the thing is, I can't find the diagram, but actually the flow when we run the cloud run deploy command, actually the service that interact within that process is not only cloud run, but the first one is a cloud storage. First, the first one is cloud storage. So, uh, it will automatically create the bucket, then it will like upload the manifest, because now here we define source, dash source, then pointing to the respective folder, right? So it will retrieve the manifest from this folder, then upload it to the bucket that created for the cloud run here. Then it will upload the manifest here, right? You see, okay, now see this one. Then it will like bundling the manifest into zip file. You see the application zip. After that, after the manifest has packaged into the zip, the next one is will case, you see, validating service done, and then uploading source to the cloud storage done, then building a container. So it will like create an image by using that manifest. So the next service that interact is a artifact registry. Artifact registry. Okay. Oh, oh, sorry. Okay, so it will create a new repository within the artifact registry. Here, yeah, name is run deploy here. Then using that Docker file and so on, then we'll build the image here. You see, you can see the image tag, then you can click on, then see the history, sorry, the history in the cloud build. So using the cloud build to build the image, then the image will push to the artifact registry. So that's the flow. Okay, so the first one is cloud storage, then cloud build to build the image. Then once the image has successfully built, and it will push to the artifact registry here. Okay. Yeah, this is the artifact registry. Once the image has done, the next one is, yeah, create the cloud run service using the image. So actually the process is why it takes sometimes it takes longer, because yeah, not only cloud run is within that process. Okay. Then we go to the retrieval surface. Then you see the URL here next to the region. Just click on, then open it in a new browser. Okay, so actually when you first time when you see it will shows forbidden, because actually there is some next step here. Yeah, for example, to register the OAuth concerns, because we want to like log in the applications by OAuth, and then log in via our Gmail account. Here, like the OAuth consent screen, client ID, and then deploy. We redeploy the applications, and yeah, eventually the the application will look like this. Yeah, it will show like a prompt. um then you can ask something like, what is the next flight to Dallas? Then it will shows the data that will retrieve from the AlloyDB that we populate already. So actually, like we already populate the data into the database, right? So then when we prompting into the front end, it will retrieve data from there. Then by using the model, the LLM model via with Vertex AI, it will get the content aware response, like by combining both. Then it will send a better response to the user. So yeah, so how it looks like. uh, okay. Okay. Okay, this is the reference that I use for the this session and the demo itself. You can follow along. And yeah, if you have any questions, please do let me know. I think that's all. I'll send back, get over to Ria.
Hi, Ananda. Thank you so much. We'll wait for questions if there are any. Feel free to add it in the chat so that Ananda can answer them.
Thank you. Thanks, everyone.
Okay, looks like we don't have any questions. If it's okay with everyone, we would like to take a picture with all of you. I and if you're able, please feel free to, I guess, turn on your camera. I will make everyone a presenter right now. And if you're not okay with it, that's totally fine as well.
Okay, I'll stop.
Ananda, you can, yeah, thank you so much. Um, if anyone's ready to turn on their camera, that would be really nice. Okay. Okay, I'm just going to take a picture. Ananda, smile. Okay, okay. 1, 2, 3. All right. I just stopped recording.